Hey everybody, Adam Savage in my cave to talk all about robots. Specifically, when I was recently at Husqvarna's Research and Development Labs, I met Chris Price. He is the robotics engineer in charge of North American development of their Automower robotic lawnmower. Chris gave me a peek under the hood of the Automower and talked about the many ways it has evolved in the near 30 years Husqvarna has been building them. He also shared his story about exactly what it takes to enter the field of robotics today. Here we go. All right, Chris, I'm watching this mower move around, and I'm reminded of a legendary place. Satellite maker and NASA contractor Jet Propulsion Labs famously has a Mars yard where they test their rovers for Mars-type circumstances. This is Husqvarna's Mars yard.
It is. It's exactly that. So this is our obstacle course. It's our proving ground, so we can see how does the mower traverse things that are commonly found in your yard.
And I see all these different things, from raised tiles of different heights to chunks of wood. Tell me about what are some of the easier and the more difficult things for it to get past.
Yeah, and so some of the stuff we really want to focus on, especially as we start to grow the robots here in North America, is crossing between different surfaces. Right, so going from grass to a sidewalk, back to grass, going over a driveway, going over paver stones. Those are the kind of things that we don't want our customers to have to move, or they can't move them when they put the mower in. We don't want them to have to modify their landscaping, to make the mower work necessarily.
Your goal is to meet the customer where they are.
Exactly.
Gotcha.
And that's one of the things that's it's a big focus point for us, because we've been proving these machines for decades in Europe. But one of the things that we see that's very common in the North American suburban yards is this division with sidewalks and driveways and things like that. And what we'll see over time is, if there's an unlevel transition, it's just this kind of never-ending, incessant impact on the machine. And we have to understand, making sure that the machine is traversing these obstacles in a way that's the least impactful.
So then, as you guys look at European versus American lawns on the aggregate, you find more potential collision hazards in American lawns that just, you need to make sure the product can deal with that.
Yeah, I mean, it's not like we have anything here that they don't over there. It's just
sure.
The frequency at which you find certain landscape obstacles here is much higher.
That's really cool. I just love the idea that there's obviously philosophical, cultural differences about this stuff.
Yeah, I mean, and the thing too is you'll see is just we have, on average a little bit bigger areas.
Yeah.
But the big thing we have often is a separation between areas. We have a front yard and a backyard. We have all these different things. There's roots and trees and things you have to get around. And so we simulate some of those things. Like tree roots is a big one for us. You see over there, we actually use, a molding type material.
Yes. That's what that's for, to be like the...
Because we want to make sure, so our machines, they're very intelligent about their surroundings.
Yeah.
But we have to make sure, is it actually understanding when is something that could be a problem and when is something that I need to react to, right? It's like, the driving over roots, shaking the machine, vibrating, we don't want it to think something bad is happening.
It's happening right as you're saying it. This is perfect.
Yeah,
we did not plan this. That's amazing.
So
you've got to teach it what signals are worth paying attention to and what it can ignore.
Right, because I mean, again, safety and the way the machines work, make sure they operate in a safe way is our primary concern.
Now it looks like it's about to hit that and drive right over it. Oh, it hit its collision sensor.
Yeah, so the idea with those is that when the cutting height, the way the machines are designed, so that the wide body on there is actually for safety purposes, to make sure that the blade is as protected as possible.
Even if you reached around to pick it up, you'd have a hard time getting your fingers all the way around to that blade, even though you shouldn't do that.
You shouldn't do that, right? And so the idea is, the blade is protected, hopefully, from people, but the blade, when it's under normal operation, that disc might still be lower than the collision sensor.
Right.
And that's to make sure that we get the grass height. So we need to understand what is the impact over time of hitting things that might be lower than the collision sensor.
How the blade itself would deteriorate.
Right, and the whole, because we have an automatic mechanism, we need to make sure that mechanism can withstand the impact.
Is there a certain minimum number of hours you run each model on this yard?
So the exact number that's a little bit of like the secret sauce, right? Of like making sure that these things run. But I can tell you, we have a bunch of different models, right? We have models that are designed for 1/4 of an acre yard, or 3/4 of an acre yard, or 1 1/4 acres, and we all scale those, pretty dramatically. We expect these machines to last for 5 to 7 years in the customer field, depending on exactly how they've got it installed.
Yeah.
So we need to make sure that we can handle that, and then much more so.
Right.
So it's for reference, one of these machines might run for as much as 19 hours a day.
Wow.
If you have a huge space, 19 hours a day, 7 days a week, I mean, you can start to do the math. The numbers add up pretty quick.
Your goal is to break stuff here so that it doesn't happen out there.
Exactly.
Got
You
it.
know, and there's interesting things like we see like our kind of fake transition here to a driveway.
Yeah.
You know, we had to make sure that our wheels traverse that in the right way. You know, as the machines are getting smarter, we want them to follow specific paths. You know, so this is a random machine, but our e-post mowers move in systematic. And if you have to cross an obstacle.
And when you say systematic, you mean this one's sort of filling out the yard by drawing a random pattern that will eventually fill. But you're talking about a machine that actually might be able to go back on its own line and know what it's already mowed before.
Exactly.
Okay.
So it's going to look like a lot more like the traditional stripes that you would get from a normal lawnmower, which is something our customers really want. But we have to make sure that we're climbing over an obstacle, that we're trying to maintain a course.
Yes.
That, you know, we have to understand what the mower's going to do. Are the wheels going to be able to traverse that obstacle? Are they going to drive the mower sideways? Can it recover? So those are the kinds of things that we see here.
Amazing.
You know, and this is good too, because we can, through our design process, as we change things and designing new models, it's like, well, here's a different wheel profile. We can see how many errors, how many times do we have a problem here. Last time we changed something, we have a controlled test environment. Because that's the thing, is outside is not controlled.
Right.
Your backyard, your front yard, like you can't predict it. That's why we use fake grass here, because we can get a consistent surface throughout the year.
You don't need to actually activate the cutting
Right.
in order to be testing all the other stuff for this.
Yeah, this is what we say is terrain handling durability course.
Not a grass cutting course.
Right. So we have a separate area that we do actual cutting quality stuff, but that's very seasonal.
Yeah.
So this is one of the things that we can do all year round. It's like, how are we handling this? And make sure that we run these mowers so much we'll actually kill the grass. And then our course turns into a mud pit, because even though it's a small machine, it's designed for an acre of grass.
And it could overdo that.
It overdoes it. So with that, and we get to keep a consistent surface. So we can see over time, well, we've changed this wheel profile and we have less problems with this particular feature.
I noticed this guy up here in the back also running through some paces, way in the back.
That's our all-wheel drive mower. That's actually just keeping that grass cut. So,
it's actually it's not testing, it's just a function.
No, it's just keeping the grass cut.
That's awesome. All right, Scott, this is a robot. You guys make machines for all sorts of lawn care and flora maintenance.
Yes.
But this is an autonomous one. I know all the parts in here in and of themselves aren't exotic for you guys, but this thing thinks for itself. What are the unique challenges of making robots that you guys have encountered here?
What we take pride in, we've been doing this for 30 years, and so we've seen...
You've been making robots for 30 years?
Yeah, almost 30 years now.
How did I not know about this? That seems crazy that you've been making them for 3 decades. Okay.
Yeah, so it started off in 1995 with the solar mower. So again, a bit ahead of its time, right? We took 1995, we were already talking about solar-powered solutions. And that was the first robotic lawnmower that was ever introduced to the market.
Far out.
We have been in this technology field for nearly 3 decades now, and because of that, we've seen all the technology that you could possibly integrate into a system like that. But what we concern ourselves most is reliability and safety. So we don't want to introduce a technology that's not vetted for consumer markets, right? And we have a very robust system. In fact, there are 2 kind of systems that we can talk about of how this works in your yard, right? So the mower, you might be asking, well, how does it know where your yard is and where your neighbor's yard?
Is it dead reckoning, or does it understand your whole lawn?
We've got 2 technologies. The robust technology that we've been using for nearly 3 decades now is what we call our boundary wire technology. And that's just been a tried and true. It's kind of like an electric dog collar fence that goes around your perimeter of your property.
And this won't cross that?
It won't. It'll cross it about 11 centimeters or so. You can actually change that. That distance there, but it won't go. The body won't go beyond that. There's other way you can go about that, setting up that boundary is what we call a virtual boundary. So this machine right here is our 450XH EPOS. We actually launched this in 2023, so this is brand new, but this uses RTK GNSS technology.
What does that mean?
Good question. Real-time kinematic global positioning systems, okay? So it...
Wow.
Yes.
So it's using GPS.
Yes.
And that's at a granularity enough to mow your lawn.
Yeah, 2 centimeters of accuracy is how accurate this can actually get.
I'm curious, just because I was, fondling this as I came over. Are these bottle openers? What's going on with these little things?
No. So these are the charging. These are the contacts.
Oh, those are the charging guns. So it noses in and
goes
that's how
nose
it
in. That's
receives
exactly
all of its power. It's not like a slicer or something.
No, and it's very low voltage too. So it's not like you're sitting there and spending a bunch of energy for charging. It's incredibly low voltage. We actually refer to these as low power machines. Right? They're they have a lot less power than like a traditional lawnmower might have, but they still get the job done in the same way. So we can lift it just like this.
Oh, it's so light.
It's very light, yeah. No,
I didn't realize it would be that light.
It's very light. And this is all it is. It's just a little cutting disc that has blades. These are
Whoa,
razor
they
blades.
are razor blades. So instead of the big, heavy, I really was picturing the standard lawnmower, the big, heavy, monolithic, rectangular blade here.
Yeah.
Obviously, you've gone with this for lightness. What other advantages does this kind of cutting
Quality of cut. So these are razor blades. There's nothing sharper than a razor blade. So there's less tearing of the grass. Part of the whole conversation around robotic lawnmowers is quality of cutting grass, right? And one of the ways that we achieve that is by having razor blades instead of a traditional blade.
So it's like an even extra bet. You're spending more on this, you're getting a better cut.
Yeah, exactly. In addition to that, these are pivoting blades. So if it hits an object like a rock or something like that, instead of staying out and sort of flinging that rock, it will pivot into the skid plate.
That's inherently safer for us around it.
Inherently, it's not kicking rocks or anything like that. But we want to go into a really big deep dive of this mower. I can turn you over to Chris and he can go through this in nitty gritty detail.
Please turn me over to Chris. That
Absolutely.
sounds great. Thank you so much.
Thank you so much.
We are in the robot cage.
This is where they get assembled and taken apart and tested and measured. This is where all of our robots in test and in development kind of come through here as part of their process of either getting ready to go out on test or coming back to see how they did.
Okay, so I don't think most people realize just how toxic an environment a lawn is for machines. There's so many things that a lawn can do to wear down a machine. Can you talk about that?
Absolutely. So, I mean, that's one of the things where a lot of people see these and they're a little off-put sometimes by the fact that we're made out of plastic, right? Because you're used to seeing outdoor power equipment be made of steel. Zero turns, garden tractors, they're all made of steel. And they need to be because they have like very high-powered engines on them. They're doing a lot of work that they need that heavy duty. For us, the whole idea of an Automower is that it's maintaining your grass. It's doing a little bit of work a lot of time.
Instead of the big work
Exactly.
4 times a year.
So the duty cycle is different. It's kind of fundamentally reversed. And so what that means is that we can go with plastic because we don't necessarily need the really intensive vibration durability.
Right.
What we need is the stability in moisture and sunlight and all those kinds of things. And so plastic actually gives us a little bit more control and it keeps the machine a little bit lighter weight and allows us to be a lot more freeform with how we design it so we can focus on the performance and the safety of the machine.
So can we talk about the inside? Can we?
Absolutely. The way the machines work is we have what we call our inner chassis, and then we have the floating body. And the body, you see here, moves relative to the chassis.
Oh, okay.
And that's what triggers our safety switches. And so as we take this off, you can see that it
Those
pops.
are the explosive bolts?
Those are rubber grommets. And so
That's, okay.
So
and that's what the whole thing rides on, these guys.
So we got ahead and disconnected these, but these will come down, and this is for your charging plates, for your headlights, and for the ultrasonic sensors on the top. But the whole machine rides on these grommets, and that's how we kind of float and we see.
Okay, so this is sort of part of the shock system that allows it to take a lot of abuse and come back.
So that's how we detect if the machine collides with something or if something lifts up the mower. And so
that's a switch that'll stop it.
Yeah, so it's a huge safety feature we have. If anything lifts the body, we immediately kill the blade.
That's really, so, okay, I want to just dial into this for a second, because that is a really elegant, simple solution, which means it was probably hard to design.
Yeah, you touch on really the theme of how we design these machines. We need this machine to do its job more than anything. Its job is to mow the lawn without you having to go interface with it. We want reliability to be the key, and generally, to get good reliability, simplicity is kind of the name of the game. And so that's part of where you'll see that as a fundamental approach here. And that's one of the ways that we can survive outside in these kind of harsher environments is keep the moving parts to a minimum, keep the complexity to the bare minimum, and focus on how can we get the job done, how can we get the grass cut so the customer is happy, and how can we make it so you don't have to go and interface with the machine that you bought to do a job for you.
So how do you warn against unnecessary complexity? Because I'll wager there are product managers who come to you with wish lists that you have to disabuse them of, or find some mitigating way to get close to what they want.
And the beauty there is that we have both sides of everything, and there's a difference between what we send to production and what we investigate on the R&D side to see what is going to work.
Right, you try everything.
We've been doing this for 30 years, right? So we've been in this so if you could imagine a technology you could put on a robot to go outside, to help it do something. We know about it. We've even tested it. We've gone into it. And so that's the discussion with product managers. It's not like, how come you guys haven't done this yet? It's like, how well did this work when you tried it? It's a very cool device. It's a gadget, but it is a tool. It's there to do a job.
Yeah.
You know, the whole idea of a robot is that you don't have to do it anymore. And we want to put all these features in it. We want to give the customer a good experience. We want them to enjoy interfacing with the product. But at the end of the day, we want to make sure they can still walk away and go have a beer and the grass gets cut.
Now, I'm looking at this interior, and you've got some grass detritus on here, and I think that this is a fairly clean example. If this was mowing my lawn and I took the cover off, I'd probably see a lot more dirt. And I see things like the gaskets to keep that from ingressing into the internal mechanics. But like, were there aspects of shielding against the things that happened in a lawn that surprised you guys? Or that were particularly hard to harden against?
I mean, some of the stuff that we always have to kind of fight against is moisture buildup, right? You know, condensation. So the inside of this machine is filled with circuit boards, right? And we have to make sure that we're not putting them in an environment that's not going to be conducive to their surviving. Like,
but you're always putting this in an environment that's not conducive to
so we've got to keep moisture out. And so this particular model has no advanced circuitry outside of our chassis. So some of our newer models do, and we have those kind of sealed by themselves.
Right.
And so we can take this off, and you can see this is basically, we've now entered our sealed container, right? So everything inside of here.
This is not worried, right?
Right, so these mowers are IPX4 rated, which means they're rated for downward water, right? They're not designed to be sprayed with a hose, but they can be out in the rain all day and all night, and they're going to be okay. And that comes from this rubber seal that we have. It kind of goes around the entire thing.
Can I? Wow.
Yeah, go for it.
It's replaceable.
Yeah, and so that's kind of...
that is super cool.
Yeah, so we designed these to be serviceable. You know, these have a long working life. They'll last for years. We want to make sure that the things that could be wear parts that are going to jeopardize the expensive components and the brains of the operation, those are protected. So we kind of guard against them with replaceable wear parts.
So you replace this when you're repairing the machine.
Right.
That is really cool that you made it that easy.
So what you'll see is, like, we have very experienced dealers in Europe where we've been selling these for a lot of years, and they'll do a winter service on these, right? Because a lot of those are operating in Northern Europe. They have a very kind of defined winter season relative to where we are in the Southeast.
Right.
And so they'll bring these in, they'll take the top off, they'll clean them up, they'll pop the cover off, if anything needs to be replaced inside, they will. Otherwise, they'll replace the cover. They'll check to make sure that the batteries are still holding charge. They'll update the software, do everything they need to do so that when the snow melts and it's time to start cutting the grass again, it's ready to go.
Chris, can you walk me through just the basic functioning of how these all work in concert?
Absolutely. So we should start with right here, this is the battery. So our machines run off of lithium-ion batteries, but it's a surprisingly small battery, right? So this machine is rated for 1.25 acres of grass. 1.25 acres of grass, not 1.25 acres of property. Right.
Okay.
And so that could lead to 3-4 acre property. So that's quite a large amount of grass. And you can see here we've got 2 batteries that are not much bigger than the biggest battery you're going to get for your power tool.
Yeah.
In actuality, this is actually 2 identical batteries, and one of these is about the same size as your average big battery from your big power tool companies. And so it's not a lot of power. And that's the beauty of the system is, you can see this is our cutting motor. It's not huge. The whole idea here is that we're running often. We're doing a little bit of work all the time. We're cutting off, a couple eighths of an inch relative to a couple inches of grass every single time. And so it keeps the use of the machine down. And
that allows you to keep the machine this light.
Yeah, exactly. And so it also allows us to package our electronics better. So this is on this particular mode, this is the main board. And so most of the brains of the machine are either here or they're in this board over here on the top that we'll talk about in a second. But our motor control circuitry is all integrated onto here. And in future models, we've kind of distributed that out a little bit, but it allows to having, a relatively low power machine relative to traditional lawnmowers, allows us to really package this stuff better, right? The whole machine is kind of, fulfilling itself in terms of keeping it a small package and kind of lightweight and low energy. And so we go on the top, this is where kind of the fun stuff is. So this right here is our application board. So this is where kind of the brains of the machine start. Right, so this is where we connect to Bluetooth, where we talk to your phone. This is what's actually controlling the interface on the top, your start and stop button. And this is kind of calling the shots. So this machine is one of our GPS-powered machines, right? So this is an EPOS unit. So this is running off RTK GNSS, and this is our RTK unit right here. So we have a board that talks to satellites, and we have a board here that actually talks via radio to our local reference station. And so that's, this is really where our kind of, the the best part about this machine is.
All right, Chris, we were looking over there and you were telling me that was a fully autonomous bot moving around the obstacle course. But this one here is working through GPS.
Yes.
Now, I know my GPS is pretty good to about, I don't know, 6 or 10 feet, but it certainly isn't enough to mow a lawn. How do you get the granularity out of this?
Yeah, so the way we get our navigation from the machines for GPS is we use something called RTK GNSS. So GNSS is the generic term for positioning satellites, right?
Okay.
So GPS is the American ones. There's Baidu, there's GLONASS, there's quite a few other ones, right? So GNSS is the blanket term for all of these systems.
It's the species of
Right.
navigation. Okay.
And then RTK stands for real-time kinematics, which is like a cool, fancy sounding word. But to really distill it down is the way it works to get 2 centimeter accuracy. So the reason that your phone has limited to a couple meters is a lot of it has to do with atmospheric distortion. So the satellites, the GPS satellites, the GNSS satellites that it's talking to, are very far away.
Right.
And there's a lot of atmosphere to cover between them. And on top of that, the satellites are moving, you're moving, everything's moving around. So there's a delay there based on kind of this distortion in the signal
Sure.
that can be difficult for your phone to work out, right? And so one of the ways you can combat that is if you have 2 reference points on the ground. And so that's what we do. So our RTK system uses what we call it a reference station. So we have a local reference point.
And that's that antenna up there.
That's our antenna up there. So, and you want to put that one generally relatively up high at a clear view of the sky, because the whole purpose of that is that it doesn't move.
Right.
So it knows I'm not moving.
So you have one control point that the rest of the equipment can bounce off of,
Exactly.
and then it has a much better idea about where it is.
Yeah, so basically this one will sit still, and it can guarantee it's sitting still, collecting information from the satellites, and it does some complicated calculations to basically build a correction factor. Say, okay, you're within a 20-kilometer radius of me. I have generated this correction factor for our atmosphere in this spot to make sure that you can use your GPS better.
All right, so before we continue, though, I just want to confirm, this is a production unit. I could buy one of these today.
Yes.
And it would come with one of those antennas.
Correct.
With instructions to put it at a location. Now, once that's up, is there a getting the mower to know the land kind of moment where you give it some specific, I don't know, whether waypoints or boundary points?
Yeah, so the first thing you do is you set up the reference point. And once that is established connection with the satellites, then you can go ahead and install the mower. So that's where you would actually walk the dog, drive the mower, and that's where you'll dictate your boundaries.
So you
actually
walk
draw
this mower to the edge of your property and
then
tell it where that is.
Yep, and so we have to make sure these mowers run safely, we have to be very specific about defining our work area. We have to work here. So there's a couple aspects. There's safety, there's also to make sure you want it to mow right. Like, if your area is not precise, it's the difference between cutting your grass and the mower falling in your pool, right? Or cutting your neighbor's flower bed. And so that's the beauty of our ecosystem with 2 centimeter accuracy.
Oh God, I'm sure both of those have happened, haven't they?
Unfortunately, only when people don't follow the installation instructions, right?
Fair.
Yeah.
And that allows this to have, how tight is its accuracy? I realize that may be a trade secret, but it's way less than a meter.
2 centimeters.
2 centimeters?
Yeah.
1/50th of a meter.
Yeah.
Wow.
And so that gets us to a point where we can reliably say that this mower is going to provide a really, really nice quality of cut, really well-defined areas. And the cool thing is you can map out the areas where the mower is allowed to go. We call them work areas. You can also map out the areas where it's not allowed to go. So this tree bed here is what we call a stay-out zone. And so you can map this whole area, and you have a tree or something, we define another GPS-based area there, and the mower won't go there. Amazing. And all of this is done through driving the mower around, kind of mapping these areas. But once you have them mapped, you can go into our app and you can edit them, you can change them around, you can change the settings. That's where you could go. You could actually change the pattern at which it's cutting, you can change the height at which it's cutting. So all of these things are possible with these virtual cutting areas. Whereas our older technology, using the boundary wire, it's very reliable, it's very kind of low cost, but there's a bit of a labor-intensive install process. And once it's there, it's not very flexible.
Right.
So the beauty of the GPS system is it's super flexible.
That is really thrilling. All right, so I'm literally just telling this bot where to go. It's a big, fun remote control car.
Yeah. So right now, this is how we can do our mapping process. So we call it walking the dog. And what you do...
of course you call it walking the dog. That's awesome.
Yep. So basically what you do now is you're defining your area. So you'll make a full area, like a shape of that maps this yard. So here you would drive the machine around, drop points all along the outside, and when you finish it, you come all the way back around and it'll complete the shape.
Amazing.
And then once you have that completed shape, that defines where the mower is going to be allowed to work once you start going.
And this also, like, if you are a landscaper and you got to like dial in some specific area, this might be exactly what the doctor ordered.
Yeah, and then the good thing about it is, so what we use this point-based system. Some systems where they'll do is they map the area, tracking the mower exactly the whole time. And you'll see it can be a little bit difficult to get the precision you need. So with our point-based system, you can get up to a curve and you can only drop the points exactly as you need them. So you can get a pretty tight shape for your working area.
Oh, that's really, so I could actually mow my own name in my lawn if I had a lawn and I was willing to do that.
You could map out your work area just in the shape of your name. And so then it would leave, what we've seen people do is they'll have two different heights where one, they cut something shape in a little bit lower and they have the rest around. But at the end of the day, this is a machine that's cutting your grass and that's what it's supposed to be doing. And we need to make sure that paramount to all of that is it's doing that safely.
Oh man, thank you for letting me take this dog out for a walk. He's delightful. What kind of treats does he like? Like AA batteries?
He just loves grass.
So
He'll munch on grass all day.
So do I. Who's a good boy? Who's a good boy? Excellent. Dude, that is super fun.
Isn't it cool?
Chris, I'm not being facetious about this question at all. I am sure there are young people watching this wondering, how do I get the job to be a manager of robots and to do stuff like this? Can you talk about your journey to Husqvarna?
Absolutely. So background is electrical engineering. So I literally grew up playing with robots. I was building these kinds of stuff, when I was a kid, getting robotics kits in the early days, kind of getting into a little bit of programming. I mean, even before Arduinos and things like that got super popular, you're kind of playing. I was always the gift I would get from somebody. It was like some electronics kit, some kind of thing, right?
You were that kid.
Yeah, I was that guy. And so I knew that that's the route I wanted to go. And so robots was always interesting to me. It was always something that I loved. It was not the target. There's a lot of people who's like, I'm going to go into robotics, right? But I knew, so I went to school for electrical engineering. Through that program, I learned like electronics and embedded systems, what we call this, is something I'm really interested in. And so that's kind of where I started to specialize. And then after school, I was really fortunate to get into a rotational program with Husqvarna. So we have a program called the Global Pioneer Program now. It was called the Global Trainee Program at the time, where I actually got to travel the world and spend rotations in different parts of the company. Wow. So we're a huge global company. We have offices all over the world. We have main headquarters in Sweden and we have one in Germany. And so I got to go spend time with all of the different engineering departments that were working on batteries and electronics and robots. And so that was this amazing kind of door opening experience for me to get within the company. So I graduated from school, I came to Husqvarna, and 3 months later I moved to Sweden.
Wow, they got you right out of, fresh off the boat.
Yeah, so I spent 9 months in Sweden and I worked on kind of some innovation projects. I worked on our battery handheld stuff, which you got to see. So I was in some of the early testing we were doing on chargers and stuff like that. And then I got into the robotics, working on some of the electronics developments, so like some of these sensors here. I was actually on, on a team where we were working on updating those kinds of things. Spent some time in the purchasing side, which is a huge aspect of electronics these days.
It sounds like it's a really useful rotation to have.
Yeah, guys. So it was like a non-technical rotation, but it's almost necessary. If you're going to start playing in electronics, you need to understand where they came from because they impact design.
Right.
Like
it's part of the cost benefit.
You don't just
analysis.
get to choose what part you want necessarily because it might. Yeah, maybe we can afford it, maybe we can get it, but can we get 10,000? Can we get 100,000 of them? And what happens there, right? And can we get them in time for production? That's at the time when I was there, the lead times were not as big of a discussion, but I mean, post chip shortage, it's become our main focus is when we build these machines, can we get the electronics? We're way out ahead of the game on lead times. Where that's our primary focus when we're kind of going through these. Spent some time in Germany. We have a sister brand called Gardena, and they have their own R&D department working on their own products, and so I got to see a different side of the company. When I came back to North America, it was 2018, and that was where we were really starting to say we want to focus on growing robotics in North America. So I've been kind of a point person for the technology side of robots since then, and which is huge because, like I said, our business for robots is in Europe, and we have an incredible R&D department there that does amazing work. And being able to kind of connect the two was huge. That's been a huge part of my career is making sure that it's the people side, that the people are connected. Right. The technology kind of we can bring, but we have to make sure that the right people know the right things. And so that's been a big piece of this is people think of engineering and STEM as just very tech focused, but there's a huge people side of STEM work, right? That you have to make sure that there's a lot of opportunities to cultivate that, and that could be really useful in your career.
Well, it always struck me, all of my friends who have CS degrees, that computer science draws people who like to think systemically. They like to think of the long tail of each of the decision trees. And it sounds exactly like You have found a fantastic home here at Husqvarna.
Yeah, I mean that's the beauty of it is like it can be daunting at first to say, well, there's this whole team in Sweden. I got to reach out to them and ask them a question, get in the door, and you realize, oh, they're also just engineers. Like they're also just a bunch of nerds. Like we can all get along, right?
You're all pulling on the same rope.
Exactly.